Let's explore how to work with cross-sections in the GrasshoppertoAXISVM add-on. Our new component called Deconstruct Cross-Section is introduced in this video, as well as an improvement, the selection of multiple cross-sections from the AXISVM cross-section library with one component. First, I create a parametric cross-section. Click on the arrow to open the list of cross-section shapes. I select the rounded rectangle shape now. The input parameter list of the component is automatically adjusted to the selection. Clicking on the Show Image or Hide Image button, user may display or hide the sketch of the cross-section with the signs of the cross-section parameters. I connect the panels to the input parameters. The input values must be in meters. As soon as I fill all necessary inputs, the parametric cross-section is defined. I connect the output of the parametric cross-section component to the brand new component called Deconstruct Cross-Section, and the output parameter names are immediately adjusted to the parameter names of the input cross-section, and the numerical values are available on the output. As second, I use the cross-section from text component. I connect the name of the cross-section I want to find in the AXISVM cross-section library. The component returns the first occurrence of this cross-section name. If I need another cross-section table, I may feed the CS table input to configure the result. If I connect it to the Deconstruct cross-section component, there's a warning message telling that the output count is less than required for an I-shape cross-section. However, the visible outputs are filled with the cross-section parameter values. I right-click on the middle of the component to open the pop-up menu and use the Match Output feature to adjust the output count and make all parameter values available. Third option is to browse the AXISVM cross-section library with the improved AXISVM cross-section component that allows to select multiple cross-sections. Double-click the left side of the component to open a form. On the left side, user can select from the shapes and tables. The list box on the right side is filled with all cross-sections of the selected table. User may select one or more cross-sections from the list using the Shift and Control buttons of the keyboard. I select now 2 strips and click OK to confirm. Since I deconstruct more than one cross-sections now, I graphed the input parameter to group the values on the output. These rectangular cross-sections have only 3 parameters. To remove the unnecessary 4th output parameter, I use the Match Output feature of the pop-up menu. I keep the first selected cross-section and create a custom rectangular cross-section based on that. For this purpose, I take the parametric cross-section component, set the shape to rectangular, and set an expression for input parameter h that is going to duplicate the received number. Then I feed the inputs with the dimensions of the cross-section from the library, give it a name, and set the process to rolled. Last, I would like to mention that the cross-sections created from thick polygons cannot be deconstructed since they do not contain information about any cross-section parameters. Thank you for watching.